Hey guys, Coach Brian going over the 1.3 and 1.4 notes for class. Again, this is for on-level geometry classes, and today was a little bit of a lot because we were covering 2 lessons in one day. And so I'm going to try to move fast. Remember, the reason these videos are helpful is because you can rewind them, slow them down, go back and watch certain parts again. So I'm going to go through this knowing that you also have access to your notes on Schoology, and you can open those up and follow along also. So just to jump right in, we need to talk about what angles are. And angles, like you see in the picture right here, okay, angles are a figure formed by 2 rays with a common endpoint. If you remember, rays are, for instance, like this is ray RS and it's ray ST. All right, I actually wrote that backwards. It should be ray SR and ST. But these 2 rays together, they share this point S. That's their common endpoint. That's also what we would call a vertex. Vertex is the common endpoint. And when you have this angle, like this example right here, there's a few ways you could name it. First thing is, all of them are going to have this little symbol in front. And that just means it is an angle, okay? The first way you can name it is just by the vertex. Angle S. You could name it angle S. Another way is through... If you see, I'll erase here since I drew over it, there's a small number inside the angle. And sometimes when you get an image, it'll say angle 2, angle 4, angle 3, whatever. This one, we could call angle 1 because it's got a 1 right there inside the vertex. And then the other way you could name it is with the letters. You could call this angle RST, or you could call it TSR. And the important thing about both of those, all right, RST and TSR, is that the S is in the middle. S is in the middle. That is our vertex. So that letter that represents the vertex always needs to be in the middle. Now, moving on to number 4, find the measure of each angle. So first of all, we have this tool. They're in the boxes at our tables. It's a protractor, okay? We use a protractor to measure angles. It's kind of hard to see, but this is actually point 0, or O, sorry, letter O. And then you can see this is B, this is C, but I accidentally left off the A right here. So if you want to go ahead and add that to your notes as you do them, that'll work. We're looking for a measure of the angle AOB from A to O to B. A to O to B. And so the way we do that, you have a couple ways, but one, neither one of these rays lies down here on the 0 line, all right? Neither one of them is there. And so what we want to do is find what they measure and find the difference between those. And when we were talking about difference and distance last class, we were talking about how it's an absolute value and how that's going to always give us a positive answer. So if I look right here, A is at 34 and B is actually at 64. And so I would want to find the absolute value of the difference between those. And so that would actually give me a negative 30, and the absolute value of negative 30 is positive 30. And so AOB equals 30 degrees. I'll let you do the other 2 examples for a little practice on your own. Just follow what I did for that first one. Next, we're going to talk about congruent angles. Congruent angles, all right, this word congruent is going to appear quite a bit. So it's really important that you know what it means. It means angles that are the same size, shape, and we could also say that they're the same measure. They have the same measure in degrees. So that would be matching angles. Moving ahead to the angle addition postulate, this pretty much says we can take two angles and combine them. Okay, angles can be combined into larger angles. So if you have part of an angle and you add another part, you get a whole angle. All right, two parts can make a whole. Another way is if we have an actual image. You see we have two angles here. I'm going to put one in red and I'm going to put the other in blue. Well, if I could draw a straight line, I'm going to put the other one in blue. And you can see that those two angles are side by side. The one that I put in blue is angle TRS, and the one that I put in red is angle QRT. And together, they make one bigger angle, QRS. And so those angles that were added, angle addition. If you look down at examples 4 and 5, we have a couple of practices. The first one says if the measure of angle FEG is 67 degrees and DEF, DEF is 48 degrees, find DEG. So I'm looking for the whole larger angle that these lines create. I'm looking for the green angle, the measure of angle DEG. And so what I have is I have a part and I have a part, and I want to figure out what is the whole thing. So if I look back up here at the angle addition postulate, I have a part plus another part, and I put those together and I get the whole thing. So DEG, the combination of these two angles, is 115 degrees. I'll let you try example number 5 on your own. It's a little bit different. It gives you one of the parts and it tells you what the whole thing is. So you've got to find the missing part. In this case, it would be angle YWZ. All right, so last class we talked about we actually talked about segment bisectors, and we talked about bisector meaning to cut into two. And when it was a segment bisector, it was something that cut a segment into two equal parts. Same concept here. An angle bisector is a ray that divides an angle into two equal parts. So if you're ever working a problem and it says like, hey, this is a bisector, you know that what's on either side of it is equal matching halves of the original angle. So in this case, if BC, ray BC, is the angle bisector of ABC, so that lets you know that this is half and this is half because that bisector goes perfectly down the middle. So if that's true, then we could say that, this is actually a little typo, sorry. I'm just realizing this as I'm working on it. This should say ABD, and so angle ABC would equal angle CBD. We would say the two parts equal each other because they're bisected. I'll let you do example 6 on your own. It talks about KM bisects this angle JKL. Okay, so that lets you know this is half and half. With that knowledge and what they give you, see if you can figure out what JKM equals. This is what you're looking for right here, JKM. All right, so that kind of wraps up 1-3, which looking back over it is all about what angles are, how to measure them, and how to find missing pieces of information when you have combined angles. Moving on to 1.4. Okay, moving on to 1.4. I'm actually going to make a separate video. Just that way you can focus on 1.3 if you need to focus on that. 1.4 if you need to focus on that. So if you got 1.3 and you need help with 1.4, just make sure that you look for the next video specifically about 1.4.